FTIR, Fourier Transform Infra-Red Spectroscopy. It is a technique used to analyze the molecular composition of a sample based on its interaction with infrared light. The sample is prepared for analysis by either placing it directly on an infrared transparent material or by making a thin film or pellet of the sample mixed with KBr, that is potassium bromide. An infrared light source emits a broad spectrum of infrared light covering a range of wavelengths. It's usually from 400 to 4000 wavelength. The emitted infrared light is directed towards the sample and it interacts with the molecules in the sample. The light causes molecular vibrations and rotations within the sample. The specific chemical bonds within the sample absorb infrared light at characteristic frequencies which are unique to different functional groups and molecular structures. For example, a CO single bond O, C double bond O single bond H, C single bond H, these all have different frequencies, for example. These absorptions result in changes in the intensity of the transmitted or reflected light. The transmitted or reflected light from the sample is collected and directed into an interferometer. The interferometer divides the light into two beams, one that travels through the sample and the other that bypasses the sample. So the bypasses the sample, that is called as reference beam, and the one traveled through the sample is the sample beam. The two beams are then recombined, creating an interference pattern. This pattern contains information about the differences in the intensities of the samples and the reference beams. The interference pattern is detected by a detector which converts it into an electrical signal. The signal is then processed by a computer to obtain the infrared spectrum of the sample. Usually, when making pellet of KBr with the sample, the amount of sample would be from 2 to 5% and the rest 95% would be KBr, potassium bromide. That's a usual case. In case if the amount of sample which is exceeding from 5%, maybe 10 to 15%, the peak height would be low. So less the amount of sample, more the peak height. So at the end of this experiment, you can see I have compared both the results of 2 to 5% as well as 10%. So you can see the peak height. The resulting infrared spectrum is plotted as a graph of the intensity of absorbed or transmitted light as a function of wavelength or wave number. Peaks in the spectrum correspond to specific vibrations or functional groups present in the sample. The infrared spectrum is analyzed to identify the functional groups and chemical bonds in a sample. Comparisons with reference spectra or databases can aid in the identification and characterization of the sample. FTIR spectroscopy is widely used in various fields such as chemistry, material science, pharmaceuticals, forensics, and environmental analysis for qualitative and quantitative analysis of samples, identification of compounds, and monitoring chemical reactions. So we'll place our sample as well as KBr and we'll crush it so that it may mix very homogeneously with the KBr powder, and then we'll keep it in a hydraulic press in order to press it and make it as a pellet. The standard pressure kept in the hydraulic press is 7 tons and we keep it for around 2 minutes. Once the pellet is prepared, we are ready to keep the sample in the FTIR spectroscopy. After 2 minutes, release the pressure and remove the sample mount from the hydraulic press and then remove the sample. Since it is a little bit hard, give some hammering in order to remove the sample from the mount. Instrument should be calibrated before the testing. Usually the FTIR instrument is calibrated like every week. So if you have any doubts before testing, you can check the report. So here you can see the report. So there you should note like all the calibration should give you the results pass, and also you can check the date. So date wise calibration is available. So this calibration is done by running a reference sample with non-spectral features. This helps to ensure the accurate and reliable measurements for an unknown sample. Then we should check for power. The maximum power and the current power should be same. It should be around same. So here we can see those two values are almost similar. Then we should perform background measurement. The background measurement is performed by collecting the infrared spectrum of an empty sample holder or the reference material without the sample. This accounts for any background noise or absorption due to the sample holder or the environment. So for different tests, the background should appear in different shapes of curve. So you can see few references here. So FTIR, Fourier Transform Infra-Red, it has a background spectrum different from FTIR combined with ATIR. ATR FTIR stands for Attenuated Total Reflection Fourier Transform Infra-Red Spectrometry. This is one type of test. Then we have direct FTIR. So there we don't mix with the KBr, that's potassium bromide. There are incidents we prepare samples with KBr. So here we mix the sample as a powder with the KBr. So this is potassium bromide added FTIR. Then we have FTIR with microscopy. So these different types of testings, they need different background setups. So the background graph which is shown here should appear on the screen while you are testing your sample. So if the background test results shown here and that background which is appearing on your test time, if it is different, then there is some problem. You need to check it. So the reference background and the background which is appearing while doing the test should appear the same for each test. So this background is different for each test. For ATR FTIR it's different, for FTIR it's different, for KBR FTIR it's different, for FTIR added with microscopy it's different. So it is unique for each test. Here is the additional mount for ATR FTIR, and the one you see here is the background for the ATR FTIR. So you see here this one is different from the previous background I showed. Then we will place the prepared sample in the FTIR. Ensure that the sample is properly positioned to optimize the signal collection. The sample should be thin enough to allow sufficient infrared light to pass through. So this is the reason why the peaks are low. When you add more amount of sample, the palette will become more thick and the precise results or precise peak may reduce. So when you add less amount of your sample with the KBR, the thickness of the pellet would be less. So the sample is thin enough to allow sufficient infrared light to pass through. So this is the reason why when you add more amount of sample, the peaks become low. Then we can set the instrument, the measurement parameters such as the spectral range, wavelength or wave number range, resolution, that is the number of data points per centimeter, and the number of scans. So these things we can set. These parameters may vary depending on the specific analysis requirements. Then initiate the measurement by running the FTIR instrument to collect the infrared spectrum of the sample. The instrument collects the intensity of transmitted or reflected light as a function of wavelength or wave number. Then it will appear on the screen. After completing the measurement, the raw data can be processed using software provided by the instrument manufacturer. Common processing steps such as baseline correction, normalization, smoothing, and peak identification. So here you can see there are few kind of vibration kind of things, right? So we can smooth this data. And peak identification, so each peak, when we interpret, we can identify which peak refers to which wavelength. So here we can identify which peak refers to which bond of a sample. Say for example whether it's a CH bond or OH bond or NH bond or C single bond O or C double bond O, or like so such kind of different bonds can be identified and interpreted based on. Based on this, you can analyze the processed spectrum to identify the characteristic absorption bands and functional groups present in the sample. For this, we can compare the spectrum to reference spectra or databases to aid in the identification. Quantitative analysis can be performed by comparing peak intensities or using calibration curves if available. For example, cellulose has strong absorption peaks in the range of 1050 to 1200 wavelength range due to the COC, C single bond O single bond C, and COH vibrations. Similarly, hemicellulose typically shows peaks in the range of 1730-1740 this range due to the acetyl groups. Then pectin has characteristic absorption peaks with most prominent at a broadband from 1740 to 1745 range due to the carboxylate groups. Similarly, pectin also exhibits absorption peaks in the range of 1370 to 1400 centimeter range due to the C single bond O stretching vibrations. So these are few examples on identifying the functional groups as well as the structures. So once you are done, clean the instrument for the next test. Here you can see the graph which is on the top of the screen, which shows the sample with less amount of sample, less amount of KBR, so thin pellet. The graph which is in the bottom of the screen, the second graph, that one shows more amount of sample, maybe around 10%, and more amount of KBR, and therefore thick pellet. So when the thickness of the pellet increases, the preciseness or sharpness of the peak reduces.